Bienvenidos, Hushamdi, and welcome to this HUT8 networking Techtorial. In this Techtorial, I'm going to be covering one of the most common questions that I receive when talking about Open Shortest Path First, or OSPF, when it's used as the PE to CE routing protocol in an MPLS Layer 3 VPN environment. And that question is, can you explain the different OSPF route type values that I see that are being reflected as BGP OSPF extended community values? So let's go ahead and dive in and talk about what those route type values are, what they can be, and how we can simulate the different route type values to see under what circumstances would I see a route type value of 5:1 or maybe 3:0. So the first place that we want to go is we want to go take a look at the RFC in which the OSPF route type BGP extended community attribute is discussed, and that's RFC 4577. If I was to find route type, you can see that we've got some different route type indicators here early on, but we're looking for this section right here. Now, it says that the BGP extended communities, extended type field values, are defined as follows. And so we've got some different values that we can have here for the OSPF extended community attributes. Remember that when you redistribute OSPF routes into BGP on the provider edge router, those routes are going to get packaged up as VPN v4 updates. And in order to maintain as much of the OSPF traits and characteristics, as many of the OSPF traits and characteristics as possible, we use BGP extended communities to do that. And you can see right here that the OSPF route type is going to have the extended community type of 0306, but when we search further down for the route type values, we're going to see exactly what the route type is. So here is the OSPF route type extended community attribute. You can see that the first value, which is going to be 4 bytes or 32 bits, it's going to be represented in dotted decimal notation. It's going to look just like an IP address. However, it's representing the area number. Now, the next field over, which is 1 byte or a single octet, is the route type. And now if we come back to our PowerPoint presentation and we take a look at the different values that we might see, you may see 1:0 as the route type and the options value. You may see 2:0, 3:0, 5:0 or 5:1, and then 7:0 or 7:1. So let's talk about the route type and the option values, where these values come from, and how we can simulate each of these to see that this is the scenario where I might see on a provider edge router when I take a look at the BGP VPN v4 routing information. Why am I seeing the OSPF route type of 1:0? Maybe it's 7:1. So let's start at the top here. When we're talking about the value 1:0 or 2:0, that route type value and options field value of 0, what that represents is that the PE router is learning about that OSPF prefix from an intra-area LSA. Again, coming from the same area that's shared between the PE and the CE router. So if it's 1:0 or 2:0 in those last 2 bytes, it means that the PE router learned that OSPF routing information from an intra-area LSA type. Now, if you see 3:0, it means that the PE router learned that information from an inter-area LSA type, or a type 3 summary LSA. Now, the last 2 types are typically the most confusing for learners because we have the options field value in play. As a quick note, remember, with a type 1, type 2, or type 3, your options field value is always going to be 0. In other words, 0 means no options are set. So for type 1, type 2, and type 3, it's very simple. When we get to type 5 and type 7 LSA information, the options field counts. So when we see 5:0, that means it's an OE1 or an external type 5 route. When we see 5:1, it means it's an OE2 or an external type 2, right? Type 5 OE2 route. When we see a 7:0, it means it's an N1, so an NSSA N1 route. And when we see 7:1, it means that it's an NSSA type 2 or an N2. So an easy way to think of this is when you see 5:0, just add 1 to the options field, and that's going to tell you what the type is. So if it's 5:0, it's an OE1. If it's 5:1, it's an OE2. 7:0 is an N1, and 7:1 is an N2. So now that we understand the different values that we can see in the last 2 octets, the first or leftmost value being the type, the route type value, and then the final octet being the options field, let's take a look at this from the command line perspective, and let's see if we can manipulate our updates so that we can look at each of these in turn. So if I was to go out to the CLI, I simply have 2 routers here. They're connected back to back via a serial link connection. And so if I was to draw the topology up right now, we have router 8, and it's simply connected to router 9. Let's drag that over a little bit further. And it's connected to router 9. Now, router 8 is going to simulate my CE router, or the customer edge router, in this MPLS L3 VPN scenario, where between the CE and the PE, we are running OSPF v2 as the PE to CE routing protocol. Router 9 is my PE router. Now, in order to check these values and to walk through this demonstration, I've configured router 9 simply as sort of a pseudo provider edge router. There's nothing behind router 9. There is no MPLS core behind router 9, but we don't need that to walk through the different values that we would see in that VPN v4 update that's going to get packaged with those BGP OSPF extended community values. All right, well, let's clear the screen here and let's take a look at the configurations as they stand right now. So here on the customer edge router, where typically it's very easy lifting for the customer, we have no OSPF configuration. So if I say show run pipe it to section router OSPF, you'll see there is no configuration here. Let's come over to router 9, again, the provider edge router. And here I've staged all the configuration that we're going to need. So let's take a look at that first. So I'm going to say show run section router OSPF. And when we take a look at the OSPF configuration section, again, it's a basic OSPF config. We have a router ID defined. We have the redistribute statement here. Now remember, this is a VRF aware process for VRF customer A, because again, on the provider side, we're going to be logically segmenting either physical interfaces or sub interfaces for each customer's VPN. And so again, we have a single customer we're dealing with in this scenario. It's simply customer A. So in order to start the VRF aware OSPF routing process, I simply say router OSPF. I'm just using process ID 9 and then VRF customer A. The VRF is already set up, but again, we aren't actually going to be sending any values across the service provider cloud. But if I say show run VRF customer A, you can see that we've defined VRF customer A with a route distinguisher value. Remember, that value is used to make sure that the VPN v4 updates are 100% unique when they're sent across the service provider cloud to either your route reflector and then on to other PE routers, or simply to other PE routers that this PE router would be adjacent with or would be peering with over the VPN v4 address family. You can see that I'm exporting and importing the same route target. Again, this is all kind of not that important right now because we're not actually looking across the cloud. I'm just showing you that we do have the VRF configured. We have the serial interface in the VRF forwarding customer A VRF. And so this is all set up and ready to go. If we take a look at the end of the BGP configuration, for router BGP 51, our autonomous system number on the provider edge router is 51. I have that single redistribute OSPF process ID number 9 for VRF customer A. We're going to redistribute from the OSPF process 9 into the VRF for customer A, into the BGP VPN v4 address family is where we're ultimately going to have these updates that are going to be sent. We're going to grab all internal OSPF information, external type 1 and 2, and NSSA type 1 and type 2 information. Now, let's go ahead and take a look at router 8 and what do we need to do here on router 8 to bring up the OSPF peering. So a regular customer would go into global config and say router OSPF. The process IDs, remember, from the customer edge perspective, the CE router perspective, these are 100% locally significant. The OSPF process ID does make a difference on the provider edge router, but we're going to go ahead and look beyond that right now and focus here on just the OSPF route type values that we would see. So I'm going to say passive interface default, something you might want to do, and then no passive interface, serial 000. I'm going to put my router ID in here as 0.0.0.8. That way there's no way I'm going to confuse that router ID value with an IP address. Now, I'm going to add the network statement in for the 10.88.99.8. That is my IP address on the transit segment between the customer edge router and the provider edge router. We're also in area 0. Now, as soon as I do that and right on cue, we've got an OSPF adjacency between the customer edge router and the provider edge router. So let's go ahead and let's advertise or originate a route in OSPF off the customer edge router, and we'll go look over at the provider edge router and we'll see how does the provider edge router see that. So I'm going to say 8.8.8.8, and that is simply the loopback 0 address on the customer edge router. So we come over to the provider edge router, and this is a command that you're going to become very familiar with if you're focusing or studying on using OSPF as the PE to CE routing protocol. I'm going to go ahead and say show BGP VPN v4 unicast all for the 8.8.8.8/32. Now, what is this command going to show me? Well, it's going to show me the BGP routing table, but specifically, I'm going to be looking at the VPN v4 information. And this is information that we are going to be looking for that has been redistributed from OSPF, that was learned via OSPF, that has been redistributed into BGP so that the provider edge router can then send this update as a VPN v4 update with that route distinguisher value of 8:8 prepended to the front end of the 8.8.8.8/32 out to other provider edge routers, or maybe to a route reflector who will then reflect that route out to other provider edge routers. And what are we going to see here? Well, again, remember, our focus is on the OSPF route type. Now, one of the confusing things for learners is typically when they see this RT, they think, oh, this is the OSPF route target value. This is not the route target value. The route target that we are importing or exporting, right? And specifically in this case, what we are exporting with this OSPF update, with this OSPF route that's going to go out as a BGP VPN v4 update, here is the route target value. This is the OSPF route type. Remember, under a normal scenario, if you were redistributing OSPF into BGP, when you do that, and when you do that with any routing protocol, if I redistributed EIGRP into OSPF or OSPF into EIGRP, As soon as you redistribute one routing protocol into another, you're going to be losing by default the traits or characteristics of that route as an OSPF route, or of that route as an EIGRP route. Now, in an MPLS L3 VPN scenario, when we go to do that redistribution over the MPLS L3 VPN super backbone, when we're using OSPF, we use these extended community attributes to try to maintain as much of the OSPF information for the route in question as we can. You can see we've got the route target. Now, that's a BGP extended community attribute. We've got the OSPF domain ID. Now, all this is the OSPF process ID represented in hexadecimal format. You can see right there, there's the 09, and that's representing process ID 9. Again, our focus is here, and so let's talk about the values in the OSPF route type. Remember, the first 4 octets, or the first 32 bits in dotted decimal notation, are the area number. Now, I'm actually going to change this to 51 when we get to the NSSA example. However, right now you simply see 0.0.0.0. So it's literally the OSPF area number between the PE and the CE router in dotted decimal format. Then we have the next octet, which is the route type. Now remember, this is a very important value. This is the value indicating how, or I should say, what type of route did I learn, or how did I learn this? And this is an intra-area route. So we see 2 representing that it's an intra-area learned route. If it was a 3, it would be an inter-area learned route. If you see a 5, it's an external learned route. A type 7, it's an NSSA, meaning it's an external coming through that NSSA area. Now, the final octet is the options field. Remember, type 1, 2, or 3, the options field is always going to be 0. So when I was on router 8, the customer edge router, I originated network 8888 and I dropped it into area 0, the exact same area between router 8 and router 9, between the provider edge router and the customer edge router. Therefore, it's learning it and reflecting that, hey, this is an intra-area route. So now let's go ahead and let's walk through the logical conclusion of each of the different types going to 3, 5:0, 5:1, 7:0, and 7:1. Now, over here on router 8, I've got another prefix ready to go, show IP interface brief, and you'll notice that I had a loopback 88 because we're going to leave loopback 0 advertised in area 0. So for loopback 88, this would be simple. I could go do a network statement right here since I'm under this configuration for the OSPF process ID 8. I could put a network statement in here. Another way to do this, and my preferred way, is to just simply go under the interface, loopback 88, and say IP OSPF, the process ID of the process that's running here on the customer edge router, and then simply say area 88. So I've now originated the 88 network from area 88. And again, the loopback address allows me to simulate the origination of a prefix from another OSPF area. And since I'm already peered to the provider edge router over area 0, I could go ahead and do this. I'm not breaking, I should say, the need to be connected to area 0 because this router has an interface in area 0. I could create multiple loopback interfaces and place them into multiple different areas because it's still connected to area 0. In fact, if I said do show IP OSPF 8, and I put the process ID number in there, this is an extremely handy command, because you can see right here that the router is an area border router now. Now that I've originated a prefix from another area, not area 0, and I do have an interface on this router connected to area 0. it now thinks it's an area border router. So it's an ABR. So I can go ahead and use loopback interfaces to do that simulation. And that's just a quick side note there. So back to the topic at hand. If I come back now and I say, show BGP VPN v4 unicast all for the 88/32, what do you think we're going to see? If you're thinking quad zeros, :3:0, you would be right. Because how did the PE router learn about this LSA? It learned about it with the peering with the CE router, but remember, the CE router is originating it in a different area. It's an inter-area type 3 LSA. That's how the PE router learned about this information, and that is the route type value that we're going to see. We're going to see a 3. If I was to say show IP route VRF customer B, customer A. Customer A. And let's take a look at that routing table. You can see right here, that is an intra-area route for the 8888. But when we look at the 88 network, we see that it's an OIA. Because where did it originate? It originated from area 88. Now, we're an ABR. We have an interface connected to area 0, so that's going to work just fine on the customer edge router. What if I said show IP OSPF database? I'm going to see that we've got a summary, type 3 summary LSA here for the 888888. And so again, the provider edge router, that is how it's learning that information. That is how it's going to reflect the value for the 88 network. Again, we would see 3:0. All right, let's now go ahead and let's change things up a bit. I'm still under the interface. Let's pull that advertisement out because now we want the 88 network to be redistributed into OSPF on the customer edge router because we're going to force it to be a type 5 LSA at this point. Now, full disclosure, I already have a prefix list and a route map so that I can limit the advertisement when I do a redistribute connected statement, but I'm going to show you what those are right now. So do show run, and I'm going to include prefix list. And again, there's only one prefix list on this router, and that is the prefix list right there. IP prefix list, I just called it OSPF, and we're going to permit, in other words, we're going to match the 88/32 network. Now, I also have a route map. So if I say do show run begin route map, this should take us to the configuration section where this route map is a single statement route map. It's the name of the route map is also OSPF, permitting 10, and I'm matching IP address prefix list OSPF. So in other words, this route map is only going to match what is allowed via that prefix list right there. And we've already indicated that we're matching one thing and one thing only. Remember, at the end of every prefix list, there's an implicit deny everything else. And the same thing is true of the route map. I have a permit 10 here, and there's an implicit, in other words, we don't see it in the configuration, but it's there for both the prefix list and the route map. Just like an ACL, you've got the implicit deny everything else, right? So I'm only allowing the 88/32 to be redistributed when I apply this route map statement. Let's clear the screen, and let me step back now to the CLI here, and what we're going to do is we're going to go into router OSPF 8 because this is where I'm going to be doing the redistribution of the connected networks into OSPF. And there's also a little gotcha here that you need to be careful of. So I'm simply going to say redistribute connected now. This is where I'm going to apply my route map OSPF. This is limiting out of all the connected interfaces on this router what is going to be redistributed. And again, we've already defined and explained that it's going to be that 88 network and only that 88 network. Now, there's a very special keyword that should be here, and that keyword is subnets. And I want to give you a word of caution on recent versions of iOS 15.6, 15.7, and beyond. You're typically not going to have to put the subnets keyword in. iOS is going to do that for you. It's going to protect you from making a mistake, because if I don't put the subnets keyword in here, and you're going to see this, and this is 15.1 code, an early release of the 15 code. So early that if you don't put the subnets keyword there, not only does it not put it there for you, it's not going to advertise or redistribute this information we expect to be redistributed. And let me go ahead and show you that. If I come back to the provider edge router and I say, show IP route VRF customer A, do we see the 88 network here anymore? We don't. Remember, we removed the origination statement under the interface in area 0. Or I'm sorry, area 88. So we removed that statement from the interface, it withdrew that advertisement, and now we don't see that route. Now we're getting ready to redistribute it. And I did a quick sidebar here that if I don't say subnets, it's not going to put it there. In fact, if this 15.1 code is like any other 15.1 code I've seen, we're going to get a message telling us, hey, if you don't put the subnets keyword there, I'm only going to be advertising classful routing information. And sure enough, there it is. And you've got to love it when a plan comes together. So only classful networks will be redistributed because I don't have the subnets keyword on there. Again, with recent releases of iOS 15.6, 15.7, 15.8, what I've seen is that the subnets keyword is typically put in there for you. However, that said, I highly recommend that whenever you run the redistribute command under the OSPF process, that if you're not only doing classful networks, which typically in most modern networks you won't be, you add that subnets keyword in there, right? You'll notice we don't get that warning message. So let's take a look and say, do show run section router OSPF 8. And we should now see that we've redistributed the connected subnets. And there's the subnets keyword, and we're limiting that redistribution to what is being matched in our route map that references the prefix list that is only matching the 88 network. So now when we step back over here and I say show IP route VRF customer A, we now see the OE2, the type 5 LSA representing the 88 network, is in the routing table for customer A's VRF. And so what that means is if I've got that information in my routing table for the VRF for customer A, the BGP stanza, which is for VRF customer A, is going to redistribute this information. And it's going to try to pack all those values into the BGP OSPF extended community attributes to maintain as many traits and characteristics as it can when it advertises that information over the MPLS L3 VPN service provider network. So without further ado, let's say show BGP VPN v4 unicast all for that 88 network. And what do you think we're going to see for the area value, for the route type value, and for the options field? If you said quad zeros 5:1, you would be correct. And the 1 representing a type 2, an OE2. And so there it is. Now, the area on type 5 information is going to default to quad zeros anyway, right? But we're coming through area 0. So we previously saw that. But for type 5 information, that value will be quad zeros. You can see here, there it is. It was learned on the PE router via a type 5 LSA, the options field, because by default, when you redistribute OSPF when you redistribute routing information into OSPF, like we did on the customer edge router, by default, it's going to be a type 5 OE2. 2. Remember what I said about the options field. Add 1 to it, and that's going to give you whether it's an OE2, or I should say E2 or E1, or N2 or N1 value. So I add 1 to that, I get a type 5 OE2. And that is exactly what we saw in the routing table. That is how this route was learned. So let's go back over now and conclude the type 5 conversation by simply saying, and I can simply cut and paste this, I'm now going to make this redistribution a little more interesting, and we're going to say metric type 1. So now I'm not going to let OSPF do the redistribution by default and assign it and let it assign it as an OE2. I'm going to force the redistribution to be a OE1 learned route. And again, let's take a quick look here as show IP route VRF customer A is going to show me. Right now, this is an OE2. That is the default for when routing information from outside your OSPF domain is redistributed into your OSPF domain. But now I'm going to say redistribute that, but don't do it as the default, metric type 1. You'll notice no error messages, and actually let's make sure, I always like to say do show run, section router OSPF 8. Let's make sure that that metric type 1 got added in there. It did. Our route map is still there. The subnets keyword is still there. We are golden. We come back over to the provider edge router where I'm going to say show IP route VRF customer A, where we now see an OE1. So if I see an OE1, when I say show BGP VPN v4 unicast all for that 88 network, what is the route type going to be? What is the area value going to show? And what is the option going to be? And if you said quad zeros for the area number representation, remember for external information, it's going to default to quad zeros. The route type is going to be 5. We're still dealing with type 5 external LSAs, but the options field is going to be 0. So we should see quad zeros colon 5 colon 0. And that is exactly what we see right down here. So that is when you would see this value for the OSPF route type. You've redistributed information on the customer edge side into the OSPF process, which you have an adjacency on between the PE and the CE router, and you want to set your metric types to type 1. And so that's the value that you would see for the OSPF route type. So now we're going to have a little additional work to do here. We're now going to take a look at when we would see type 7 information. Well, remember, the type 7 information is going to be when you have an NSSA. Again, that's an OSPF area type in which I'm going to be doing redistribution. So let's go ahead and set that up. So let's look at what we have right now. Show run section router OSPF. So on the provider edge side, you can see here that we have the OSPF process running on our interface between router 8 and router 9, the PE and the CE in area 0. Well, how do we fix that so that this is an NSSA? There's 2 things we need to do here. The first is, and actually let me get under the router OSPF VRF, 9 VRF for customer A. And let's go ahead and say, and let me get this straight first. Let's go ahead and say no network and pull that statement out. And we're going to add a new statement in here. And let's say network 10.88.99.9. That's my interface. I'm going to do a quad 0 so that only the OSPF process is only going to be running on that interface. And I'm going to say area, and let's go ahead and have some fun with this. We'll use area 99. Now, what we're going to see here shortly are messages popping up telling me that there's an area mismatch between the provider edge router and the customer edge router. And there you go, mismatched area ID. Because I've got 99 as the area on the PE router, we don't have that on the CE router. So therefore, we're going to get this message. Now, there's one other thing I need to do. I need to declare area 99 as an NSSA. And that's going to complete the configuration. Let's save our config here on router 9. If I step over to router 8, do show, and actually we have it right there. So let's say router OSPF 8. So I'm going to remove the network statement for the loopback 0 address. We don't need that anymore. I'm also going to pull out the network statement that had us in area 0 for our adjacency with the provider edge router. Now, all I need to do to add that back in is say network 10.88.99.8, the IP address of the interface on this router, the customer edge router, and drop it into area 99. And then, just like over on the provider edge router, you'll notice here, no adjacency coming up. And that's because the area type doesn't match. The area number matches, but the area type does not. So just like on the provider edge router, I need to say area 99 in SSA. And that's all we need to do. We're going to get a message here shortly telling us, hey, we've gone from loading to full. The adjacency is up. Now, remember, there's that message, do show IP OSPF neighbor, and we're going to see we've got a full adjacency up here between the PE and the CE router via OSPF, and we're running an NSSA area between the two. So let's go ahead and save our configuration here. Now, remember, in the OSPF config, router OSPF, in this OSPF config, I'm still redistributing the connected networks, and again, the route map is controlling that it's only the 88. So at this point, all I need to do is step right back over here to the provider edge router and say show IP route VRF customer A. And let's take a look at the routing table for VRF customer A. And remember, we had the metric type 1 on that redistribution statement on the customer edge router. So now that we've got an NSSA running between the two routers with OSPF as the PE to CE routing protocol, and our redistribute statement is redistributing that information, that prefix, the 88, as a type 1, we get an N1. So under the BGP configuration here on the provider edge router for the VRF for customer A, we go to do the redistribution. We're going to grab as many of these OSPF characteristics about this route as we can, and we're going to bundle and package that into the VPN v4 update under the BGP OSPF extended community attributes. And so what value do you think we're going to see when I say show BGP VPN v4 unicast all for the 88888888/32? The area ID, what do you think we're going to see there for that 32-bit 4-octet value? What are we going to see for the route type value? And finally, what about the options field? Well, if you said you're going to see 7:0, or I should say quad zeros, 7:0, you would be mistaken. Remember, there is the, what is that? The 99. That is the area number that we're using. So the area number for the type 7s comes in here. Unlike what we saw for the type 5s, which would be by default quad zeros, or as you would see for the intra-area information. So again, this reflects accurately the area. Now, there's the type. It's a type 7 LSA is how I learned that information. And there's no option set. So if I added 1 to that, it would be an N1. And so we can easily determine that that's what that value is going to be. All right, let's take one more look now at the final value, the 7:2. How would we get that? Well, remember, by default, it's going to be redistributed as that type 2. So if I come back over to the CE router and I go back into global config, back into the router OSPF process ID 8 configuration, I'm going to say no redistribute connected metric type 1 subnets route map OSPF. We're going to pull that out. Now, did it remove all of that? And the answer is no. If I was to say do show run section, and this is one of the annoying things here about iOS, and when you go to remove that redistribute connected command, it removed everything except for redistribute connected. So when you do that, what you've actually done is you've pulled off the route map, which was controlling the redistribution. You've pulled the subnets keyword out, and you've pulled the metric type out. So now you're just redistributing connected, right? Which may or may not be what you want. So let's pop this information back in. We're going to say redistribute connected subnets route map OSPF. Now, I don't put the metric type 1 in there. We just saw what that would look like as the BGP VPN v4 update with the OSPF route type extended community value. So we're going to do this. We're going to say redistribute connected subnets route map OSPF because by default, again, when you redistribute information into OSPF, by default, it's going to go in as a type 2, okay? So now we come back over to the provider edge router, router 9. We say show BGP VPN v4 unicast all, and now we see the 99 for the area number representation. We see that it's a type 7 because, again, it's an NSSA, but by default, that redistribution on the customer edge router was putting in a type 2, an N2. We see the option set to 1. And so this is how, when you're using OSPF as the PE to CE routing protocol, this is how BGP captures as many of the OSPF values and traits and characteristics for the specific prefix that you might be redistributing across that cloud. This is how those values are captured and packaged into that BGP VPN v4 update and then sent across the service provider cloud. All right. Well, that is going to wrap up this tutorial on OSPF route type values in BGP VPN v4 updates. Again, I thank you so much for your time. I hope this was valuable to you. I hope this clears up what these values are, where they come from, and how you can simulate and kind of walk through forcing each of these value types to show up. All right. Enjoy the rest of your weekend, and thanks for watching.